In this video, we're going to be taking the idea of proportions and extending that into this concept of a proportional relationship, and then specifically proportional relationships in tables. So the questions we want to answer in this video are: what is a proportional relationship? What does a proportional relationship look like in a table? Can I identify if a table of values is a proportional relationship? And how do you create a table for a proportional relationship? So first of all, what is a proportional relationship? A proportional relationship is when you have two things that are related by a constant or equivalent ratios. So the relationship between the two things is always a constant ratio. So an example of a proportional relationship would be if Jordan earns $5 per hour raking leaves. Dollars earned and hours worked are proportional because the relationship between them will always be the same ratio. So let me show you what I mean by that. When you look at the number of hours that Jordan works and the number of dollars that Jordan earns, this ratio will always be the same. So if Jordan works 1 hour, he earns $5. If he works 2 hours, he earns $10, and so on. So these are all the pairs of values that Jordan will earn for any number of hours. So that's the relationship we're looking at here. So if we were to find Jordan's unit rate for every one of these pairs of numbers, this is $5 per hour. If he works 2 hours, he earns $10. That is also $5 per hour as a unit rate. $15 in 3 hours is $5 per hour. And you will notice that that rate never changes. It's a constant rate, a constant or equivalent rate. And that's what we mean by a proportional relationship. When the two things that we are comparing have a constant unit rate, that is a proportional relationship. So that's what we're going to be talking about. It's also important to note that every relationship will have two variables: an independent variable and a dependent variable. It's very important to know the difference between these two types of variables. The dependent variable is the value that depends on or needs the other value in order to be known. So it's important to be able to identify which one is which in a relationship, because that's how we're going to find our constant rates. And we're going to use that a little bit more later on in other lessons. So in the example above, the two variables are hours worked and dollars earned. Those are the two things that we're comparing. Hours worked is the independent variable, and dollars earned is the dependent variable, because the amount of money that Jordan earns depends on how many hours he works. So if I were to ask you a question, how much money did Jordan earn? You'd have to know how many hours he worked first, because the amount of money he earned depends on how many hours he worked. So dollars earned is the dependent variable because it depends on how many hours he worked. So what does a proportional relationship look like in a table? If a relationship is shown in a table, it will be proportional if all the ratios are constant or equal, or if there is a constant unit rate. Okay, we're going to take that idea of the unit rate. And in every table, our unit rate is always going to equal the dependent variable, which I'm going to call dv, divided by the independent variable. The dependent variable divided by the independent variable will tell me the unit rate. So let's take a look here at a table of the amount of money that Evan has saved up over 4 weeks. So here we're comparing the amount of money saved in dollars and the amount of weeks that Evan has been saving. So I have here that weeks is the independent variable and dollars is the dependent variable, because the amount of dollars that Evan saves depends on how many weeks he's been saving. So if I were to ask, how much money has Evan saved? You'd have to know how many weeks he's been saving first. So weeks is the independent variable and dollars is the dependent variable. So when I'm finding my unit rate, I'm going to take the dependent variable divided by the independent variable. So here, $20 divided by 1 week is $20 per week. That's my unit rate. And the next one, $40 divided by 2 weeks is $20 per week. $60 divided by 3 weeks is $20 per week. And $80 divided by 4 weeks is $20 per week. So Jordan's savings is constant. It's never changing. It's always $20 per week. So we would say this is a proportional relationship because all of the ratios in the table form a proportion. They're all equal. Let's look at Darren's savings. Darren's savings are, again, weeks and dollars is our dependent variable, and weeks is still the independent variable. So if I find my unit rates, I'm going to take the dependent variable divided by the independent variable. This $10 in 1 week, that's $10 per week. $40 in 2 weeks is $20 per week. $45 in 3 weeks is $15 per week. And $60 in 4 weeks is $15 per week. Now, not all of these ratios are the same. They are not the same unit rate. The rate is not constant. It's not equal. These are not equal to each other, even though these last two are. Not all of them are equal. So this is not a proportional relationship. Not all the ratios in this table form a proportion. So it is not proportional. So that's how we can identify a proportional relationship in a table. See if all of the ratios are equal, or see if they all have a constant, unchanging unit rate. So let's take a look at these tables and determine if they are proportional or not. So here we've got a table of tickets and the cost for any number of tickets here. So what we're going to do is find our unit rate. So our unit rate is going to be the dependent variable divided by the independent variable. And here the number of tickets determines the number or the amount that they cost. So again, our cost is the dependent variable and our tickets are the independent variable because the cost depends on how many tickets I buy. So for this first relationship, $12 for 4 tickets, 12 divided by 4, that's $3 per ticket. Next one, I have $18 for 6 tickets. That's going to be 18 divided by 6, and that's $3 per ticket. And lastly, it's $24 for 8 tickets. So 24 divided by 8 is $3 per ticket. So you can see that the unit rate here is unchanging. These are all equal. It's always $3 per ticket. So the cost is proportional to the number of tickets because there is a constant rate of $3 per ticket. There's a constant unit rate in this table of $3 per ticket. It's always $3 per ticket, no matter how many tickets we purchase. And let's look at this table. Here we have hours and miles that we've traveled. And the number of miles that we travel depends on the number of hours we're traveling. So miles is our dependent variable. So our unit rate is dependent variable divided by independent variable. So 50 divided by 1 is 50 miles per hour. 90 miles in 2 hours is 45 miles per hour. And 180 miles in 3 hours, 180 divided by 3, is 60 miles per hour. These are not all equal. None of these are equal. So miles is not proportional to the number of hours because there is not a constant rate. The speed throughout this table changes. The miles per hour is not a constant rate. So that is not a proportional relationship. And then let's take a look at this last one here. We have number of bags that we're buying and the pounds of dog food that we have. So the weight of the dog food is the dependent variable, and the number of bags is the independent variable. So our unit rate is the dependent variable divided by the independent variable. And 7.5 pounds divided by 3 bags, that's 2.5 pounds per bag. 20 divided by 8 is 2.5 pounds per bag. And 27.5 pounds divided by 11 bags would be 2.5 pounds per bag. So we can see that this is a constant unit rate. It's always 2.5 pounds per bag. No matter how many bags we buy, it's always 2.5 pounds per bag. So pounds of food is proportional to the number of bags because there is a constant rate of 2.5 pounds per bag. So that unit rate is always the same. It's always constant. So pretty easy to determine if a table is or is not a proportional relationship. We just have to check all of those unit rates. So how do you create a table for a proportional relationship? Let's say we're given a proportional relationship and we have to create a table of values. The first thing we need to do is identify the constant ratio, that constant unit rate, and then use that constant ratio to create a table of equivalent ratios. So here's an example. Apples are $1.75 per pound. Create a table showing the cost of 4, 6, 8, and 10 pounds of apples. So first of all, identify the constant ratio. What is the unit rate? Well, right here is our unit rate. It's $1.75 per pound. Okay, it's $1.75 per pound, and that would be the dependent variable divided by the independent variable. So that means dollars is the dependent variable and pounds is the independent variable because the cost depends on how many pounds of apples I buy. So my pounds will go here, and the cost in dollars will go here. And we needed to create a table of values that shows the cost for 4, 6, 8, and 10 pounds of apples. So 4 pounds, 6 pounds, 8 pounds, and 10 pounds are going to go in my table there. And then I'm going to use the constant ratio of $1.75 per pound to fill in the table. So this is a proportional relationship. So every pound is $1.75. So 4 pounds would be 4 times $1.75. So I take 4 times $1.75, and that gives me $7. 6 times $1.75 would give me $10.50. 8 times $1.75 would give me $14. Sorry, I should probably write these as money. And 10 times $1.75 would be $17.50. And there I've created a table of values that shows me the cost for 4, 6, 8, and 10 pounds of apples. Easy as that. Let's take a look at one more example. A brownie recipe requires 2 cups of flour to make 8 servings. Create a table to show how many cups of flour would be needed to make 4, 10, 12, and 15 servings. So again, we have to identify our constant rate or our unit rate. So here's a ratio right here. It's 2 cups for 8 servings. 2 cups for every 8 servings. So our independent variable is the number of servings because I have to know how many servings I'm going to make in order to know how many cups of flour I need. So the cups of flour depends on how many servings I have. So cups of flour is my dependent variable and the number of servings is my independent variable. So what is the unit rate here? 2 divided by 8 is 1/4 of a cup per serving. So it's 1/4 of a cup per serving. So I'm going to use that now to fill in my table. And I know my independent variable is servings, so that's going to go here. Independent variable always goes on the top of your table, and the dependent variable will always go on the bottom. So this is going to be cups of flour. And I wanted to know how many cups of flour it would take to make 4, 10, 12, and 15 servings. So now I know that part of my table. So now I just need to use this unit rate to help me fill in the rest. So if I have 4 servings and every serving is 1/4 of a cup, I'm going to take 4 times 1/4, and 4 times 1/4 is 1. So that would take 1 cup of flour to make 4 servings. 10 times 1/4 is 2.5. So it would take 2.5 cups of flour. 12 times 1/4 is 3. So it would take 3 cups of flour, and 15 times 1/4 is 3 3/4 cups. So there we now can see how we can see what a proportional relationship is. It's a relationship that has a constant unit rate, and then we saw what it looked like in a table. all of the values have a constant rate or all of them are proportional to each other. And we can check that to see if a table is proportional, and we can use that constant rate or that unchanging unit rate to create a table of values.